In part 2, we are looking at Tim's bank account. We are comparing the amount of dollars he has versus the number of months. Number 1 says how much money does Tim put in his bank account each month. So if we look and see, at 0 months he's got $100. At 1 month he's got $50. At 2 months he's got $200. So it looks like he is putting in $50 each month. So for number 1, we can say $50. Number 2 says, what mathematical term can we use to describe the number we found in number 1? So that number that he's adding each time, which we used to think of as a common difference, we can also think of as the slope of our equation. So we can write slope for number 2. Number 3 says, what are the coordinates at 3 months? So if we look at 3 months and we go up, we get to 250. So the coordinates would be 3 and 250. Number 4 says, write an equation using your information from number 1 and number 3. So we know that we're adding 50 each time, or that the slope is 50, and we have this ordered pair 3, 250. Now, in order to write the equation of this line, I'm going to take you back to think about Module 1 when we were writing explicit equations. And a lot of the times we did that, we used a table to help us. So let's look at what the table would look like with the information that we have. So if we went with x and y, and we have the coordinate 3 and 250. And what we're doing each time is we're adding 50. So to get from one to the next, we're adding 50 each time. And actually, I ran out of space. I want to move this over just a little bit so it's a little bit easier for us to see. So let me just move that here. So we have that point 3, 250. And remember, from here to the next point, we're adding 50. So plus 50 each time. So if we think about the way that we used to write our explicit formulas, this is going to be the same concept. So in our table, the y value we're starting with is 250. So we would say y equals 250. Then we're adding 50 each time, so plus 50. And notice that our x values are starting at 3 because that's the point that we're using. We represent that with an x minus 3 in parentheses. So taking that idea of the explicit formula and using that again to help us in this problem. Then we can take a look at number 5. Number 5 says, what are the coordinates at 5 months? So if we look at 5 months, so we go to 5 months, we go up to 350. So for this one, we would say this is the point 5, comma, 350. And 6 says write an equation using your information from number 1 and number 5. So again, let's take a look at a table, just like we did in the last one, to get us thinking in that explicit form. So in that table, we would have x and y. So this time we're starting with 5 as our coordinate, and y is 350. But again, we're using that same slope where we're adding 50 each time. So if we write that equation, we get y equals, we're starting with 350, we're adding 50 each time, and because our table is starting at 5, we have x minus 5 in parentheses. So just like we were doing for our explicit formulas. Then if we get to number 7, it says, how much money did Tim start with in his bank account? What mathematical term can we use to describe that number? So if we're thinking about what he started with is going to be before any months have been had or any money has been deposited. So we're looking at a month of 0. And at a month of 0, he had $100 in his bank account. So we can say for number 7 that he started with $100. And another term for that is because this is lying on our y-axis, we call that the y-intercept. Okay, then if we take a look at number 8 is asking us to simplify your equations from number 4 and number 6. What do you notice? So let's take number 4 and simplify it. So number 4, we had y equals 250 plus 50 times x minus 3. in order to simplify this, the first thing we would have to do is distribute the 50, or multiply it inside the parentheses. So we will get y equals 250 plus, if we take 50 times x, that gives us 50x. And then we want to take the 50 and multiply by the 3. So this 50 is being multiplied by everything inside. So 50 times 3 would give us a minus 150. Then if we go to simplify, we can combine the 250 and the negative 150, and that's 100. So we have y equals 100 plus that 50x. And again, to get the 100, I just added 250 minus 150 to get a 100, and then we still have that 50x. Now if we do the other one, this one started with y equals 350 plus 50 times x minus 5. Here we could distribute again, so the 350 is going to come down. Then we're going to take 50 times x, which will give us 50x. And then we need to take the 50 times the negative 5, which would give us negative 250. Combining our like terms again, we can combine 350 and negative 250. 350 minus 250 is 100. So we get y equals 100 plus 50x. So one thing to note is that our equations here, are the same. We get 100 plus 50x in this one, and we get 100 plus 50x in this one. So they are exactly the same, which means no matter what point you choose in your graph, as long as you're using the right slope, you can simplify it down and get the same equation. Number 9 says, how can you relate the number you found in number 7 to the simplified equation in number 8? And what I want to just point out to you is in number 7, we said 100 was the y-intercept. I want you to notice that that y-intercept is in the equations that we simplified. So this shows us that we have the y-intercept and the slope. Again, the y-intercept and the slope. So we're relating that y-intercept to the equation that we just created, and this is referred to as slope-intercept form. We have the slope and we have the y-intercept. Number 10 says, what information in your equation from number 6 can we use to help us graph an equation in this form? So when we take a look at question number 6, which is up here, if we wanted to graph this, what we need is to take out the point and the slope. So remember, the point was 5 and 350. So we would use the point, 5 and 350. And notice that within the equation it's a minus 5, but our actual point is a positive 5. And that's a tough thing for people to remember, but try to remember that, okay? So it's a minus 5 in here, but it's actually a positive 5 in your point. And then we're also going to use that constant difference or constant rate of change, which we call the slope, and that is 50. And all we need is a point and a slope in order to graph. So we can get that point and that slope directly from our equation. And lastly, we were asked in number 11, what information in your equation from number 8 can we use to help us graph an equation in this form? So when we're looking at number 8, we're looking at this simplified form, the 100 plus 50x. Again, there's the same. And so what we can use here is we can use the y-intercept and we can use the slope. So for this one, we can say we can use the y-intercept. And remember, the y-intercept is an ordered pair. That's the point 0, 100. And we can use the slope, which is also 50. So depending on whether you have your equation in slope-intercept form or in point-slope form, we can get enough information to graph.